Today's tough topic treated in 2 minutes is Newton's third law. So we usually teach students the third law. I mean, even in grade school, people learn about it as, for every action there's an equal and opposite reaction. And, what I have to tell my students in physics is it's not quite enough to just learn about it that way. You have to add some more language to it and a little bit deeper understanding the further we go along. So anyway, the real idea is that anytime two things interact at all, any kind of interaction between two objects, that the forces that one exerts on the other is going to be exactly equal and opposite to the force that the other one exerts on it. So it's always about forces, and it's about that equal and opposite business in every interaction, which is, this is an easy one to learn, like to memorize, pretty easy anyway. But to put it into action, it's sometimes a little tricky. Like, for instance, our bottle here. If I drop the bottle, and of course, this is my effort to gain advertising dollars here, of course. But anyway, if I drop my bottle here, what makes it fall? Well, most students would say, gravity for sure. And they'd be right, So I say, well then, okay, if it's gravity, then what's the force acting on the bottle, right? They usually say, well, it's a force of gravity. Really, it's its weight, right? It has a weight. That's the action of gravity, the acceleration of gravity on its mass. It pulls it down, okay? No problem. Also, I got that to balance there when I dropped it. I just thought I'd show you. Okay, it takes a little bit of skill to do that anyway. Okay, so so it gets pulled down, right? So where's the action and reaction in that? Well, most people would say the Earth is pulling it down, and they'd be right, okay? But where's the reaction to that? Well, is there? It seems like the bottle's the thing that's doing all the moving, right? So what is happening here anyway? Is there really a reaction to this? I don't see anything else reacting. Well, what it is really is it's the bottle pulling back on the Earth. And that seems crazy to believe that, right? That this little bottle would be having an equal and opposite force to the Earth as it pulls on it, right? But that's, in fact, what's happening here. Every time you have two things interacting, in this case it's the interaction of the gravitational force of the Earth on this and the gravitational force of this on the Earth. Imagine this thing having a gravitational force, really. But it does, and so there's an equal and opposite forces system going on here. So what else we want to notice about this? Well, it brings in the second law, and the second law says that if there is an unbalanced force on something, that its mass times its acceleration equals that unbalanced force. So the way that plays out here is that this thing's mass is very small, right? So therefore its acceleration relatively is big, and the Earth, in this case, its mass is really, really large, so its acceleration is actually very, very small. So really both Newton's second and third laws are played out here in this dropping of the bottle. Action and reaction, and also the second law.